Hello everyone, this is Dhananjay. We are back again. Okay, last class we discussed about the derivation on series resistance and parallel resistance. Very important one. So and today's concept will continue with our journey with electricity, and I have come out with a new concept. Guess what? Electric power. Okay, what is electric power? Okay, what do you mean by power? Actually, basic thing is power, right? So you have already learnt in the 9th standard power. So power means, what is the definition of power? Rate of doing work. Yes or no? Okay, rate of doing work. Last year it is there, one lesson for you, right? What is that lesson? Work, power, energy. Okay, in that lesson you already learned that what is the power? Rate of doing work. What do you mean by rate? Time. So whenever you are comparing something with time, we call it as a rate. Okay, so rate of doing work. Work means you are doing a certain work with respect to time, that gives power. Okay, so you know that, right? So something, potential energy, that is a work. So when do we say that energy? When do we say that energy? What is the relation between energy and work? You have energy, right? Then you can do work. So there is a interrelated energy or, work. So which means if you can choose anything, so you can replace both energy or work. Did you understand? So energy means if you have energy, you can do work. So you are working means you have energy. The capacity to do work is called energy. Okay. So now we are working on it, right? So now rate of doing work by time, or we say energy by time. Okay, that is called power. But here we are discussing about electric power. So what is electric power? Yes, we are not giving out any work here. We are not spending any energy here. We are not spending any energy by time, or we are not doing work by time. So instead of that, what do? We are consuming. Okay, what we are consuming? Electrical energy, rate of consumption of electrical energy, rate of consumption of energy. Which energy? Electricity. Electrical energy. Electricity is also a form of energy, right? So now we are just using electricity, that is called electric power. So what is electric power? Rate of consumption of energy, or you can also rate of doing work, that is the general power. But here we are not producing any work, or we are not spending any energy. So instead of that, we are consuming. So how much energy we consume per given time is called electric power. Okay, rate of consumption of energy. So we write that definition, simple definition. Power is equals to energy by time. Okay, energy by time. So energy. Okay, so what is the SI unit of power? You know that, right? SI unit is what? Watt or W. W is the SI unit. So now here, rate of consumption of energy. Which energy? Electrical energy. Okay, so electrical energy we are consuming. So here we will take energy by time, or we can also say that work by time. So if you have energy, you are working. So we are making the things to work, right? Which are the things to work? Electrical energy we are consuming. So to make to turn on the fan. So we are getting the work done from who? Electricity. We are getting the work done from electricity. We can say that power is equals to work by time. So power is equals to W by T. Okay, and W. So where have we seen the work done? In potential difference. What is potential difference? What is potential difference? Work done on a unit charge to bring from one point to another. Okay, so the V is equals to W by Q. Okay, W by Q, that is called potential difference. Work I am doing on a charge. Did you understand? So now V into Q is equals to W. So we are using that. So power is equals to what? W by T. So instead of W we will use VQ by T. Okay. This can also be written as this can also be written as V into Q by T. So this can also be written as P is equals to VI. This is the expression of electric power. Okay. So then what is electric power? So we are consuming energy, right? Energy per given time. That is called power. And here, so we are you have turned on one fan or something. So how much power it is spending the device depends on product of voltage and current. Okay, instead of electric power rate of consumption of energy also you can write. Otherwise it is a product of potential difference to current consumed by the given device is also called as a power. Okay, so P is equals to VI is the expression for power. So we say that 1 watt of power. When do we say that the 1 watt of power? When 1 volt of potential difference, it is in between the two ends of the conductor, and it is if 1 ampere of current is flowing through it. We say that 1 watt of power. Okay, and also another unit is there, watt. So volt ampere, VA. So volt is the SI unit of potential difference, and A is the SI unit of ampere. So VA also we can say. So whenever if we say that, so this also expression is very important. They may ask you to derive. So P is equals to VI you have to write. So now P is equals to VI. We know that we will use Ohm's law here. Okay. So according to Ohm's law, so we have some expressions about Ohm's law. First I will replace with V. So V is equals to, according to Ohm's law, V is equals to what? IR. So when I substitute here V, instead of V I will substitute IR into I. So P is equals to I into I square R. So this is the first expression of power, and this is the second expression of power. Okay, so electrical power can also be written as square of the current flowing through the circuit and multiplied with the resistance. So this is also another expression for power. So again we are going to use the same expression, P is equals to VI. First I replace for V, now I replace with I. So according to Ohm's law, I is equals to what? V by R. So when I substitute V here, V into V by R, so that P is equals to V square by R. This is the third expression for electric power. Okay, so very important children. So for the point of problems, very important, they will give you 2 marks or 3 marks. Calculate the electric power. So like that, if they give you, you have to use any one of these equation. Okay, which are the equation for power, electric power? P is equals to VI, P is equals to I square R, P is equals to V square by R. So these are the three expressions for electric power. Okay, so now, so P is equal, now let's move on. So electric power is equals to, right? Now we are going to discuss. Okay, electric bill. So how do we calculate electric bill? So we have told you that we are consuming energy, right? So in our electrical wire, electrons are there, but still we pay electric bill. Why do we pay electric bill? What does the BESCOM or CHESCOM, all this, suppliers of electricity, right? So why do we pay electric bill for them? Because they provide us energy. Okay, they make the electrons in the wire to move through it. Okay, so that is called electric energy. So that's how we will we will pay electric bill for it. Okay, electric energy. So we know that power is equals to what? Power is equals to energy by time. Okay, or energy by time equals power. Okay, energy by time is power. So energy equals what? Power into time. Okay, so we pay, the units. So we pay electrical bill for units, right? 1 unit some rupees. Okay, unit. So units and all we will pay bill, right? Electric bill. Why do we pay bill for them? So we know that energy is equals to power into time. Okay, so power SI unit is watt. Okay, watt, and time SI unit is second, and if it is in watt and second, the SI unit of energy is joule. So we will say that watt second or a joule is the SI unit of energy. So now we will use 1 unit of energy. Okay, when do we say that 1 unit of energy? If the product of these, if the product of power and time is 1000 watt hour, then we say that 1 unit of energy. Okay, so we have consumed 1 unit of energy if we use, see for example, see here 60 watt bulb is there. Okay, we are using normally 60 watt bulb is there now. So that 60 watt bulb, what happens if you use for 20 hours? Okay, so 60 watt bulb if you use for 20 hours, it will be 1200 watt hour. 1200 watt hour. 1200 watt hour means you are consuming 1.2 units of energy. That is the meaning of that. Okay, did you understand what is 1 unit of energy? So 1 unit of energy is called actually 1 kilowatt hour. Okay, 1 unit of energy means how much? 1 unit of energy, 1000 means 1 kilo watt hour. So watt hour, 1000 watt hour. Okay, so you are using 60 watt bulb for 20 hours. Okay, you have a small LED. So otherwise, TV and all, how much it will be around, how much? 200 to 300 watts, 200 watt. So into 5 hours, suppose you are using TV for 5 hours, then how much energy you have consumed? 1000 watt hour of energy you have consumed. So which means you have consumed 1 unit of energy. You know what is the electric bill in Karnataka for 1 unit? So 1 unit is almost around 6 rupees. Okay, this is how you have to calculate the electric bill. So you have to sum all the, it depends on the power of the given device. Power of the given device and how much time you are using. So 1 unit means 1 kilowatt hour. So this is what you should know. Okay. So what 1 kilowatt hour means, what it is in SI unit. Okay. 1 kilowatt hour means 1 kilo means 1000 watt into 1 hour. Okay, so which means 1000 watt into 1 hour means how many seconds? 3600 seconds. So 3600 followed by 123 watt second is 1 kilowatt hour. So 1 kilowatt hour means 36 into 10 to the power of 5 joule. That much of energy we are consuming. That much of energy we are consuming. Okay, did you understand? This is in SI unit. Okay, small, it's not a small amount of energy, it's a big amount of energy. So that is 36 into 10 power 5 joule. This is how they will ask you express 1 unit in J. So if they ask you 1 unit in J, you have to write this for 1 mark or 2 mark. Okay, so 1 unit means 1 kilowatt hour, which means 1000, from here you can write. Okay, 1 unit means 1 kilowatt hour, which means 1000 watt into 1 hour. From here also, no problem. from here. 1 unit equals 1 kilowatt hour into it's 1000 watt into 1 hour. So that you will get 36 into 10 to the power of 5 J. Okay, this is how we will calculate the electric bill. Okay, so one example we can give to calculate the electric bill. So consider a fan and TV. Okay, so how to calculate electric bill on this? So consider, okay, we will write device, okay, we will write power, and we will write time, and we will write energy. Okay, energy is equals to what? Power into time. Consider a device, for example, fan. So fan of power, you know, just you can just say that 100 watt of fan is used for 10 hour. So next, TV of 500 watt used for 20 hour. Calculate the electric bill for the month if they ask you. Okay, so every day we are using this, right? So energy is equals to what? Power into time. When you multiply both, 100 into 10, you know how much? 1000 watt hour. Okay, so 500 into 20, how much? 5 2s are 10. This is also 1 2 3. So 10 and 10,000 watt hour. Okay, so therefore total how much? 0 0 1 0. So 11,000 watt hour. Okay, 11,000 watt hour. So right, so 1 unit means how much? 1 unit equals to 1 kilowatt hour. So total energy used, total energy used how much? 11,000 watt hour. Okay, how do you convert something to kilo? For example, you see that 1000 grams. So 1000 grams, how do you convert to kilo? So 1000 divided by 1000. Then it will convert into kilogram. Did you understand? Whenever you want to convert some units to the 1000, kilo and all, you have to divide it by 1000. So now that is equals to 11,000 kilowatt hour. You have to divide with 1000. Okay, so when you divide with 1000, it will go 101010. So you are using 11 kilowatt hour in 1 day. Okay, suppose imagine that 6 rupees is the electric bill they are charging for you. Then what is the bill for 1 day? So bill for 1 day, so which means 11 kilowatt hour. So what do you mean by 11 kilowatt hour? 11 kilowatt hour means 11 units. So how much you have to pay? 11 into 6 rupees. How much is 11 into 6? 66 rupees. That you are using for 1 day. What is the bill for 30 days? So 30 into 66. Okay, so your electric bill will be 1980 rupees. So this is how you have to calculate electric bill. So very important problem. Based on this, they will give you calculate the electric bill for a month, for a day, or whichever they can give based on like this. Fine, this is about electric energy. Now, whenever the current flows in a circuit, you know what happens? Whenever the current flows in a device, what happens? Will it use all of its energy to do useful work? Okay, will it do? No, right? So what happens? So some of its energy is wasted. Heating effect of electric current. Okay. So whenever suppose you are using a bulb or you are using a fan or whichever the things, right? So fan is used to rotate, right? Mechanic. What is a fan? So fan is something which is rotating. So that rotational is called what? Mechanical energy. So which energy it is using? Did you understand? It is using, you know what kind of energy? It is using electrical energy to mechanical energy. So that motor will be there inside the fan. So that converts electrical energy to mechanical energy. Okay, and also a battery, you know, right? Cell, we will say no cell. What makes the electrons to move in a, so what makes the bulb to glow in a, when you connect it to the cell? Okay, so this energy changes will takes place inside a cell. Okay, inside a cell you will have, you know, that there will be some chemical energy inside a cell. Okay, when you connect it to the wire through the battery, you know what happens? That chemical energy gets converted into potential energy. When it gets converted to potential energy, then the potential energy give rise to, you know what? Electrical energy. Did you understand? So that's what the law of conservation of energy says. Energy neither be created nor be destroyed, but it can be converted from one form to another form. Okay, now we are discussing about heating effect of electric current. What is heating effect of electric current? It is a heating effect. It is an effect from the current, that's all. It is a very simple way. Okay, so the source of energy, the source of energy get dissipated in the form of heat is called heating effect of electric energy. Okay, so source of energy get dissipated in the form of heat. What do you mean by dissipation? Dissipation means spread. It is given out. Okay, it is going into the atmosphere. So, for example, I'll give you. So, you will turn on a fan and you will just, you will switch on a fan for more than 1 hour. You know what happens? So, all the fans, the fan started to run more, right? When it started to run more, after some times when you touch the fan, you know what happens? On the surface, some heat energy will be developed in the fan. Okay, so what happens to that heat? That heat energy will be, where does it goes? After some times it gets cooled, right? So that heat energy will go into the atmosphere. That is called dissipation. Did you understand? The source of energy get dissipated in the form of heat is called heating effect of electric current. And here what the heat energy that we are using is a waste. Because we need only a mechanical energy, right? Only air has to come. But it's not necessary that we need the heat energy from the fan. Like that, the bulb also. So bulb also, we after turning, just keep it for 2 hours or more than that. You know what happens? So heat and it gives out, it gives us light energy. Then after sometimes what happens? That the bulb becomes very hot. So what is that hot? That is called heating effect of electric energy. Okay, the source of energy get dissipated in the form of heat is called as heating effect of electric energy. So on what factors the heat energy gets dissipated depends on. We know that energy is equals to what? Power into time. Okay, we know that energy is equals to power into time. Which energy is being dissipated? Heat energy is dissipated. Let us take heat. Heat is equals to power, P into time. And we know that we already derived the expression for power. P is equals to what? VI. So H is equals to VIT. This is the expression for heat produced in a device. Okay, how much heat is being produced in a device is given by H is equals to VIT, where V is called potential difference, I is called current, and T is called time taken through which the current flowing. Okay, so this is called H is equals to VIT. So now, we know that, right? So what do we know? According to Ohm's law, V is equals to what? IR. V is equals to what? IR. So therefore, I will replace V with I so that, IR then into IT. So there H is equals to I square RT. So this is very, very important. So heat given out in a resistor is square of the current, resistance and time, and this law is called Joule's law of heating. Joule's law of heating. Okay, so what is the Joule's law of heating? So very important, Joule's law of heating, they will ask you for 2 marks or 3 marks. State Joule's law of heating. Joule's. Okay, Joule's law of heating. So you have to write as it is what I am writing on the board. Okay, heat produced in a resistor. First point, heat produced in a resistor or produced in a device. Produced in a resistor is, heat produced in a resistor is directly proportional to the, directly proportional to the, proportional to the square of the current, square of the current for a given resistor, for a given resistor. Okay, so H is equals to I square RT is the expression for Joule's law. Now I am deriving it. Heat produced in a resistor, H is directly proportional to the square of the current. Okay, so next, heat produced in a resistor is directly proportional to the, directly proportional to the, directly proportional to the resistance for a given current, for a given current. Okay, H is directly proportional to R. Okay, the next one is directly proportional to the, directly proportional to the, directly proportional to the time through which, time through which current flowing in the circuit, current flowing in the circuit. That means H is directly proportional to T. So we will club all and you will write expression for Ohm's law. F H is equals to I square RT. H is equals to I square RT. Very important. They will ask you. We are going to do many problems based on this expression. H is equals to I square RT, and we have electric power 3 expression. P is equals to VI, P is equals to I square R, and P is equals to V square by R. Okay, so based on this is the very important, children. You have to note down Joule's law of heating. Either they will ask you Ohm's law or either they will ask you Joule's law in the question paper. Okay, you can see that, and also if they not asked any definition on this, they will ask you, definitely they will ask you the problem related to the H is equals to I square RT. Okay, this is about Joule's law of heating. So heating effect of electric current we discussed. Now what are the devices that works on heating effect of electric current? So we are all using, right, in fan and bulb and all, no, they don't needed that kind of amount of heat energy, but for a separate some devices are there. So which are they? Micro oven, electric heater, iron box, electric kettle, all these devices we purposely we want to produce heat energy from electricity. Okay, you want a water heater, so you want electric water heater is there, right? So how? So electrical energy is being converted, so there we are making use of it. Okay, so in this, so very important practical applications that we are using electrical heating effect of electric current is bulb and fuse. Okay, so what is bulb? Bulb and all right? So we are using the bulb. So right, this is called incandescent bulb that we are using. So from so many long years, but nowadays and all we are using LED bulbs and LCD and tube lights and all. So it's been we are reducing the amount of energy consumption. Okay, so now we are using the bulb. So that bulb it is made up of, okay, so it is made up of mainly tungsten. And how does the bulb works? Okay, how does the bulb works? Very important question, children. They will ask you how does the bulb works. Okay, the filament of the bulb. Okay, the filament of the bulb. So which is the filament of the bulb? So have you seen? So the bulb will be like this, no? Yes or no? So like this, right? So this is called bulb, and here this filament is called, no? This is called a filament. Okay, so this is all called as filament, and usually it is made up of a tungsten. The filament of the bulb is what does it made up of? It is made up of a tungsten. Tungsten is a metal. Okay, sorry, it is an alloy. So the filament of the bulb is made up of, it's made up of, it's made up of tungsten. The filament of the bulb retains as much as heat produced. Okay, so you know what happens whenever we pass through electricity through the bulb, since tungsten is made up of which is made up of high resistance. Okay, resistance is very high. So when the resistance is very high, you know what happens? Electron starts to accumulate all over the tungsten. Okay, we know that H is equals to what? What is the expression? H is equals to I square RT. H is equals to I square RT. And heat produces what? Directly proportional to resistance. When heat produces directly proportional to the resistance, as the resistance increases, what happens to the heat? Heat also increases. Okay, so when the more electrons started to accumulate, resistance started to, since resistance is very high, since the heat produced will be high. Okay, so then what happens? The filament of the bulb retains means first it absorbs. So how much ever the amount of heat energy is being produced, it will absorb the heat energy. So then what happens? So the filament of the bulb retains as much as heat produced and emits the heat in the form of light. Okay, so now you are seeing that heat energy only will be converted to what? What kind of energy it is being converted? Light energy. Okay, so very important, children. 2 marks or 1 marks. Explain the working of bulb. They will ask you. You have to write as it is. The filament of the bulb retains as much as heat produced and emits the heat. Okay, first what happens? It becomes very hot. So when it becomes very hot, what happens? It becomes very hot. It retains as much as heat. Then what happens? It just emits. Okay, did you understand? You know about what is one Venus, planet, that is called morning star and evening star. How does the Venus star it shines? Okay, it is fully made up of carbon dioxide. Whenever the sunlight passes through the atmosphere of the Venus, first it absorbs so much of amount of heat, then it becomes more overheated, then it emits that heat in the form of light. So it reflects the light. So that is the reason for the the source of light in the Venus. So this is how the filament of the bulb works. And one more question, why does the tungsten, see why we have to use only tungsten? See, we can use the other things and all, but tungsten is very efficient for us. That's why we will use only tungsten. We can use nichrome wire also and some other alloys also we can use, but we are using mainly because it is very relevant and it is comfortable for us to use in bulb. Okay, so who invented bulb? Thomas Alva Edison. Now tungsten. So why do we use tungsten? Because it has 2 points. Okay, so why do we use tungsten? It has high melting point of 3380 degrees Celsius. This is one of the best reason. That's why we are using tungsten as a filament of the bulb. Okay, it has high melting point. It will not melt very easily. See, suppose instead of tungsten, if I use some other nichrome or something I told, right? So instead of when I use that, you know what happens? When the heat produced will be more, then if it reaches to its melting point, you know what happens? That filament will, you know what, melts. Did you understand? But here, tungsten will not melt easily. Okay, did you understand? How does? Okay, tungsten has high melting point 3380 degree Celsius. Okay, and one more reason is it does not melt easily at high temperature. Okay, it will not melt easily at high temperature. It has a high melting point of 3380 degrees Celsius, and it does not melt easily at high temperature. Okay, this is the reason we are using tungsten as a filament in the bulb. Okay, and also it is thermally isolated. Thermally isolated in the sense it is not kept in contact with any of this. It kept it separate. Okay, that is called thermally isolation, and it is supported with some glass which is an insulator inside. Okay, and it is inside the bulb. It is filled with inactive nitrogen N2 or argon gases. Okay, it has filled with an inactive nitrogen and argon gases. Why we are going to fill that? To prolong the life of filament. Very important. To prolong the life of filament. Okay, so to prolong the life of filament, we are going to use inactive nitrogen or argon. Okay, nitrogen and argon are, you know, right? They are the elements. So they will fill inside that. Whenever you just touch it and make it to open, you know what happens? Then definitely bulb will get burned. It will not work. Okay, because it keeps, you know, all the gases out of it. So in that gas only it can able to, you know, produce light. So these are the very important things. Prolong the life means to increase the life. Okay, it has to, we can use for more, you know, more time. So that's why we are going to use inactive nitrogen or, you know, the other things in the bulb. The next thing is we are going to use is we will use in the fuse. Okay, so we are going to use in the fuse. Then what is a fuse? Okay, a device which is made up of a piece of wire with high resistance and low melting point. Okay, this is called fuse, and you are seeing fuse here like this. Okay, it will be like it has a piece of wire like this, and the current will be flows through like this. And it is a olden days technique that we are using, children. So fuse, you know, they will fix near the, you know, near the meter board. Okay, or something like that. So they will connect like there. So they will have a different kinds of fuses we have. Okay, so one is connected to the, you know, what, near the, you know, street lamps and all, right? So here, which is made up of a metal or an alloy, of a fuse is a device which is made up of a metal or a piece of wire which is made up of a metal or an alloy. metal or an alloy with high resistance and low melting point. And here you are seeing MCB. So this is the new technique here. So MCB and all, no in detail and all you will learn in the upper classes. So, and fuse is the old old method of saving our devices. Okay, so what is the function of the fuse? Very important. Okay, function of the fuse, whenever the current flows more than the specified value, whenever the current flows more than the specified value, fuse melts and breaks the circuit. Melts and breaks the circuit. Okay, so that we can protect our electrical appliances. Okay, very important, children. This they will keep asking this, very important and very easy. Okay, what is a fuse and what is the function of the fuse? Okay, keep repeatedly they will ask you. So whenever the current flows more than the specified value, fuse melts and breaks the circuit so that we can protect our electrical appliances. So you have a meter right here, meter or something. So here what happens? Here the fuse is connected in what? Series connection, like this. Then it is connected to the home, your home and all the electrical appliances, whichever they are there, they are all connected like this. Okay, it is always connected in what kind of connection? Series connection. Okay, it is connected in series connection with the electrical appliances. Okay, fuse means it is a some kind of fuse that we are using. So it is connected near it is always connected near the meter port. Okay, whenever the current flows more than the specified value, what happens? Fuse melts and breaks the circuit so that we can protect our electrical devices. Okay, this is about fuse. This is the old one. See, if once the fuse melts, then we have to buy new one and then we have to fix it. Okay, so next, so what is current rating? Okay, current rating. Okay, what is the current rating? The maximum allowable current, the maximum allowable current through the fuse is called current rating. See, the maximum allowable current, how much current has to pass through the fuse? There is some fixed, the current that the fixed current amount of current has to pass through the fuse. That is called a current rating. Okay, did you understand? The maximum allowable, how much current you can allow, so that is called as current rating. The maximum allowable current through the fuse is called as current rating. So some fuse will have 5 ampere of current rating, 10 ampere and 2 ampere. So depending on the which one we are using in a current. Suppose in our homes and all we need around more than that 10 ampere and all, right? So but in electrical devices like in a street lamps and all, in the higher transformers and all, they need more amount of fuse is being kept. Okay, suppose if the current rating is 10 ampere, so example I have taken. So what if the current flows exactly 10 ampere? Will the fuse melts or will it melts or not? That is the question. So actually current rating is 10 ampere. So the fuse will not melt because it is exactly equal to the current rating. So if the current flows more than that, at least 10.1 ampere, 10.2 like that, fuse melts and breaks the circuit. So this is called related about the current rating. Okay, so this completes all the theoretical part that I have discussed in the previous sections, all the sessions. Please watch all the videos. Okay, all physics lessons we are going to teach you in YouTube, and please support us, so that subscribe, and also you can know whatever the doubts you have. And also I have given you the description in the description box. I have given you the Telegram link. You join there. I will send you more classworks and related questions, all the CBSE and state board. And also the next upcoming classes I am going to discuss about the problems related to all the theoretical parts related to whatever we have discussed in the from first session to this. So problems are very, very important. You will get definitely a 1 mark one problem either for 3 to 4 marks definitely. And all the theoretical part, whatever I taught you, just make a keynotes and keep learning. And also I'll post you the classwork of electricity in our Telegram link. Join us. Until then, take care.